Very good. Well, good morning,
Okay.
everyone. Yeah, I see where the session is now being recorded. So I will go ahead while folks are still going to be logging on. Everyone also has a copy of the agenda. It is up on your screen, but I know we also sent that out. So we might have some folks kind of calling in and joining us later in the morning. That's but my name is Heather Wendt with the Benton Conservation District. I'm the co-creator of the Heritage Garden Program, and I want to welcome you all for joining us today for our webinar, Sharing the Love for Native Plants and Pollinators. I want to especially thank the Washington State Conservation Commission and Alyssa Carlson for providing the service for us today so we could reach out to folks during these very challenging times. We're being sort of creative, so hopefully this platform will provide an opportunity for us to get together. Even though we can't see you in person, we can still get together and share information. This was originally supposed to be our Yakima County Heritage Garden Workshop, so I do want Yakima Heritage Garden sponsors, the municipal subgroup of the Yakima Basin Integrated Plan, funding provided by a grant through the Washington State Department of Ecology. So special thanks to all of our partners today. And with that, I'm going to turn it over to Ann Autrey. Ann is my Heritage Garden Program Coordinator for Yakima County. She is a native plant enthusiast, she has her own native plant nursery, and she's just a phenomenal partner. And so I'm going to change my screen over to Miss Ann's so she can do her presentation.
Good morning, everybody. It's so exciting to be our first webinar. I'm glad you're able to join us. I'm sorry we couldn't meet in person, but this is, I guess, the next best thing. And so we'll get started. We have a great program today with Cathy Reed and Cy, and then Bob Gillespie talking about entomology and the native pollinators for our native gardens. I would first want to give a brief overview of the Heritage Garden Program. I know I have 15 minutes, so I will be really fast, but I'd like to make sure everybody is aware of what the Heritage Garden is about. I know a lot of you have signed up or I visited your places, but there are quite a few people that names I didn't recognize on the registration, so I thought it'd be good to do a little overview. So let's go ahead and get started. So Heritage Gardens are, of course, our water smart landscaping and honoring the heritage of the Columbia River Basin. The program is brought to our community by the North and South Yakima Conservation Districts, the Washington Department of Ecology, and the Yakima Basin Integrated Plan in partnership with the Benton District and the Columbia Basin chapter of the Native Plant Society. Heritage Gardens are landscaped areas designed to honor the cultural and natural heritage of the Columbia River Basin while utilizing sustainable gardening practices. So what does that mean? Well, Heritage Gardens promote the use of native plants, especially those of cultural significance. They promote low water use landscaping and efficient irrigation methods. And we educate our community about the history and biodiversity of the Columbia River Basin. How do you get a Heritage Garden? Or how do you become certified? So creating the Heritage Garden is a mix of the flora, fauna, geology, and cultural significance of our region. And there is a checklist for which when I come out to certify your garden, that I will go through and make sure that you recommend or the required practices. And then there's a couple of recommended practices. This checklist is available on the website for those of you who might, in Yakima County, who might have a Heritage Garden and you meet the the required practices, I can come out and certify you. It is not a garden that I have to design or Heather has to design. It's just it just has to meet the required practices. So the plants are from native plants from the Columbia Basin is what we would like to highlight, just because of the fact that they are generally low water use and are also extremely beautiful. And our native pollinators love those plants. And they have high cultural significance from our indigenous people, Lewis and Clark expeditions. Let me show you what I'm talking about here. The flora requirements. So what do you need to do in terms of, for a heritage garden, the flora requirements are at least 5 different species of plants, plants that are placed in locations that meet the requirements for water, light, and soil conditions, 75% native to Washington State, 30% needing less than 10 inches of water annually, and no more than 10% needing more than 30 inches of water annually. The fauna requirements in terms of wildlife, we need to have at least 2 species that have wildlife value. Cultural significance, indigenous people. We want to incorporate the ethnobotany of the tribes into your heritage garden by including plants used for food, shelter, and medicine. Heritage gardens must include at least 1 species of cultural significance. Also, in terms of cultural significance, is the Lewis and Clark expedition. And we can include into your heritage garden species noted by Meriwether Lewis's journal. And so again, at least 1 plant species needs to have be of cultural significance. Geologic features. Basalt floods shaped the predominant geologic features of the Columbia River Basin. And so we would like for there to be a geologic feature included into your garden. And so it's not that hard. It could be as elaborate as a basalt column. It could just be using large basalt for mulch, crushed basalt for mulch or footpaths, river rock. You can use a basalt rock for a bench or used flood tumbled boulders. Other required practices that we would like or that need to be in your heritage garden is an irrigation system designed to apply appropriately for each planting zone, and the initial watering to establish plants for gardens that require less than 10 inches of water. And so you can see using the drip irrigation directly to each plant in the photos. Other required practices include weed control, and you cannot have any prohibited plants in your heritage garden. And so we use the noxious weed plant base or list on the Washington State and the USDA plant date website. Also, Heritage Garden does need to comply with all county, city codes, laws, ordinances, and HOA rules, if that applies to you. When you've met this, all of those required practices, you receive a beautiful landscape, beautiful yard sign that you can post into your garden, and everybody can see it. And it's very striking, and it shows your neighbors and friends passing by that you cared enough to have a heritage garden in your yard. Available to people requesting a heritage garden. Site visits from myself include information on creating a heritage garden. That means efficient irrigation methods, weed control, hardscape options, plant selection based on soil type, sun exposure, and the amount of precipitation. I'll create a personalized plant list for your garden and then design a planting plan for your garden space. And finally, certification of your heritage garden when it's all in place. Resources online. We have a wonderful website available, www.hgcd.info, that allows you to look at plant lists. You can look at vendor lists. You can also take virtual tours of gardens that exist, heritage gardens that exist in Benton and Franklin County. Yakima County, what a huge success we had last year. It was just phenomenal, went beyond all of our expectations. The program officially started in November of 2018. We held the first Heritage Garden Spring Workshop in March of 2019. I conducted 11 presentations in 2019 and 2020. We had our first fall workshop in October of 2019, and I certified 6 heritage gardens in 2019 and now in 2020. In terms of site visits, I conducted my first site visit in March of 2019. Since that time, I have visited 74 sites between 2019 and 2020. We had 60 of those sites in 2019, 14 right now in 2020, before our Stay Home, Stay Healthy order took effect. Created 68 individualized plant lists and then designed 63 heritage garden planting plans. And that includes for people in terms of in their homes, businesses, nonprofits, one for a school and one for a state park. So just an unbelievable, and really in a year, since I did my first site visit in March, my last site visits were in March of 2020. So in a year, done 74 site visits. It's pretty amazing. Also, I want to make sure we have just published a brand new resource that's made for the Columbia River Basin. Plant Selection Guide, Heritage Gardens of the Columbia River Basin. This is by our own Heather Wendt and Donna Lucas. And it is an amazing book designed to help you with plant selection of your heritage garden. And as you can see, it's a spiral bound book, and it contains stunning photographs and descriptions of over 100 native and low water use plants. It provides information on the cultural and natural heritage of the plants. And I do have copies available. It's they're $27 each. And go to the Columbia Basin chapter of the Washington Native Plant Society. And those costs just to go to recover the costs of printing. And so I do have copies available that I can now mail out to you. If you just contact me, email, we'll talk about the mailing costs to get you your book. So it's just a great guide, and there's nothing else like it to help us with our plants, with selecting the native plants for our heritage gardens. Also, we've expanded into Yakima County in 2018 with the partnerships with North and South Yakima Conservation Districts, with funding provided by the Washington Department of Ecology through the municipal subgroup of the Yakima Basin Integrated Plan. And in January 2020, we entered into agreement with the Central Washington chapter of the Native Plant Society on implementing the Heritage Garden Program in Yakima County. And so down below are all of our partners. And thank you very much to all the people listening who are part of that, part of each of those groups, and we appreciate your support. And finally, North, if you need to contact us or the Heritage Garden Program, the North and South Yakima Conservation Districts are a way to contact us. Website has our contact information there. And then my email, direct email, is listed down below, and you can feel free to email me with questions, or if you need advice, or if you would like me to send you a book, whatever, whatever it has to do with Heritage Gardens. So thank you very much, and I hope you enjoy the rest of the program today.
Wonderful. Thank you so much, Anne. Alyssa, do we have any questions in the question box for Anne?
No questions yet. So yeah, if you have any questions for Anne, go ahead and enter them into that questions box.
Yes, sounds wonderful. Well, to keep things moving, we're going to go ahead and so if you have questions for Anne, go ahead and type them in. We'll come back to those. Anne, would you like to introduce our next speaker?
Yes. Cathy Reed is our next speaker. She is with the Central Washington Native Plant Society, or the Central Washington of the Native Plant Society. She's the president, and she's going to talk to us today about what the Central Washington chapter does and their activities. So thank you very much, Cathy. We really appreciate it, and we'll enjoy your program.
Okay, can you all hear me okay?
Yes, sounds great.
Okay, well, I thought I'd start off by talking a little bit about the history of our group. In the mid-70s, there were several University of Washington and Seattle, and they started thinking about creating a group to conserve and study the native plants and their habitat in Washington state. These four former and eventual chairman of the botany department at the UW were instrumental in forming and leading the WNPS in its early days. Leo Hitchcock, who's seated on the left, co-authored a 7-volume set of books that describe all the plants that are known in the Pacific Northwest, with a key and illustrations to help identify any plant that you might find in the wild, including any non-natives you would find as well. Since it's really hard to carry around a set, it soon became evident that they needed to consolidate into a 1 volume. And for years until 2018, we used that volume, but in 2018, with help from the Native Plant Society, Burke Museum, and the UW, and a whole bunch of other people, a new version of that 1 volume book was created. Art Krukeberg has historically been considered to be the founding father of our organization, but I'm not exactly sure why. He was maybe the first president, but Dr. Melinda Denton also assisted a group. She was a nationally renowned botanist who pioneered studies in how plants relate to and evolve from each other. So our society is all about protecting, appreciating, studying, and understanding native plants. Because any plant is a native somewhere in the world, we're focused on those native plants in the Pacific Northwest, and particularly in Washington state. Well, how do you define that? So native plants are those that were present within the current borders of Washington state before European contact, which was about 1800 or so. And how can we tell if the plants were already here? Well, journals from Lewis and Clark and homesteaders, conservation districts, and other naturalist writings were consulted. And what that really means is for the future, if you're a person who likes to get out and you take good notes, your notes could be of significant value to those that come after us. So we're also interested in algae, fungi, and lichens, and that's because they're intimately intertwined with the proper functioning of our native plant species. Underground fungi help trees communicate with each other and absorb nutrients, and lichens plants and break down rocks into soil that plants can use. And the algae, well, they are a combination of fungi and or lichens are a combination of fungi and algae. Besides, back in the 70s, when our group started, algae and fungi were put in the plant kingdom. So we have a brief discussion here about our organization. We have a state board that has about 25 members or so on it who guide state policy, and they tackle problems that all of us in the chapters throughout Washington face out when we're carrying out our mission. The board meets twice yearly, and once on the east side of the mountains. This photo shows a very cool rain garden that is just outside our meeting room at the Cedar River Watershed Education Center near North Bend. Our other meeting is usually held in Ellensburg in the spring so that folks can also enjoy the spring flowers and the shrub steppe when they're traveling. At the state and local levels, we have programs that are focused on education of adults and kids, field trips, stewardship, conservation. We have plant sales, and we support other environmentally focused groups. There are 12 chapters of various sizes and activity levels. Most are named for the geographic areas that they cover, but some groups took on some fancy names, including the Salal chapter, which is in the South Puget Sound area, Suxdorfia, which is southwest Washington and Klickitat counties, and Comaculshan, which includes the Mount Vernon area and some of the San Juan Islands. My chapter, the Central Washington chapter, focuses mainly on plants in Yakima and Kittitas counties. We have meetings in both Yakima and Ellensburg, depending on where our speakers are coming from or what activities we are planning for. We typically of the month from October through April, and then in the spring and summer we add to our we substitute field trips several times a month for our meetings. Our local chapter generally mirrors the priorities of our state office, but our chapter is especially devoted to doing educational activities in cooperation with other partners. We have a booth every year at the Yakima Area Arboretum's Arborfest, educational tables at other community events, and presentations on environmental topics at our monthly meetings. We also sponsor plant ID classes, plant photography classes, and most webinars like this one. This is a photo of our youth activity booth at the 2019 Arborfest. We designed an activity for kids to help them understand about how different kinds of plants can protect and shape streams and rivers. We like to focus on teaching a few key ideas to the kids and to the adults who are with them. I spent my career working along the streams and rivers of 4 eastern Washington counties, and you'd be surprised at how many folks don't know the difference between planting trees versus grass and how that could or could not protect their properties from floods. Include a lot of different types of locations and durations depending on what the objective for our outing is. We have done short hikes specifically designed for young kids to tag along, to multi-day backpacking trips where we collect seeds deep into the wilderness or forest. Most of our trips, though, are about 2 to 4 hours, depending on the travel time to get there. We're a very laid-back group, and it doesn't matter whether you are a beginner or an expert, you're going to fit right in. This is a Burnt Mountain hike in 2011. I'm not sure if it's a Yakima or Kittitas County because I borrowed the slide. This is Natchez Peak Loop Trail. We often have a lot of conversations about what species a plant is, and we usually haul big books around with us just because of that. But one of the reasons that this hike is one of my very favorites, it's up in the national park, is because you get scenery like this. Spectacular views, and even this photo doesn't do it justice because This is late in the season. If you're there a little bit earlier, instead of green, you're going to be seeing blue from the amazing amount of lupin that live up there. This is Snow Mountain Ranch, and I have to say that of all the places in the Yakima area, I spend a lot of my time on Cowiche Canyon Conservancy lands. This is another view at Snow Mountain Ranch along a trail in probably 2018 or 19, I don't remember which. But you can see how how protecting the land can bring some of the native wildflowers back. This is another view on Cowiche Canyon Conservancy lands between Summit View and Cowiche Canyon, looking off toward Yakima in the distance. Here's a popular and easy to identify plant, at least of the genus, Indian paintbrush. This was Devil's Table, and this picture was taken just a few weeks ago up on the top. All the white stuff you can see on the ground is phlox, and what you can't see are little green tubular leaves, which will indicate the presence of one of my favorite plants in the future, bitterroot. But you know, you got to stop and look. You got to not walk too fast or drive by too fast, or you're going to miss some of the coolest stuff out there. Do a plant list, we go very slowly. I remember one time in 2 hours moving only about 100 yards because we were identifying everything we saw. But it really is amazing if you just get down and look. There's lots of other places to see native plants in the Yakima area if you just know where to go. This is orange globe mallow, which is Sphaerolaceae monroeana on BLM land at Conowalk Pass in May. We also do plant sales, and this year we did not contribute to the Arboretum plant sale, but they carried on anyway with a very successful line sale. We periodically sponsor workshops by professionals, but most of us learn by doing, and these days most cell phones take pretty good pictures. This photo came from my cell phone. This is either showy penstemon or blue penstemon. I didn't take the time to key it out. I think the most important thing when you're taking pictures of flowers is to think about your background and where the light is coming from. This is a photo from 2019 doing a winter botany field trip for the Cowiche Canyon Conservancy. We try to support different entities in our, and these are a list of some of the ones that we help out. And when I mention conservation districts in this slide, we're talking about the Heritage Garden Program as well. While we don't have a formal stewardship program in our chapter area, which is a program designed to teach anybody who wants to learn about plants and about the environment, we still provide assistance and training to other groups. And this is our native plant garden out at the Arboretum. And basically it was put on a pile of dirt in the Arboretum parking lot. We also volunteered. This is a cactus garden right adjacent to our garden. And I'll tell you what, weeding this garden is a real challenge. This is a picture of the Erigeron filifolius, but we do plant surveys, make plant lists, we review development proposals for their, and give feedback on wildlife impacts and other things. We have a lot of annual events, mostly that happen in the spring and early summer, because that's really when you can see the bloom. We have an annual photo contest that includes plant photos from the previous year that are due each year by February the 1st. The contest winners' photos are used for the following year's Native Plant Society calendar. We also offer grant and monetary awards for people that have projects. I don't know much about how to apply, but I'm sure the information is on our website. Our plant surveys, this is just a list of people we've done plant surveys for. I'm going to talk a little bit more about Moxie Bog and the Union Gap floodplain here for just a minute. Moxie Bog is owned by the Nature Conservancy, and recently we helped search for a special violet in the bog and the surrounding floodplain area. Moxie Bog is located in the floodplain of the Yakima River near Union Gap. The yellow circle shows where it's located. So a little history, the reason Moxie Bog is important is a butterfly called Beloria saline that is rare for this part of Washington. It's more common in other states, but it was found in Moxie Slough, and it was found also that it pretty exclusively feeds on a plant called Viola nephrophila. The Nature Conservancy acquired a parcel in the middle of the area in 1966 and called it Moxie Bog. Got to get the right page here. It also will feed on Viola nephrophila, or Viola palustris, and Viola glabella, although nephrophila on the left is its preferred plant. Make sure I get the right thing here. So, unfortunately, after much searching, the only place that we found the butterfly was in this portion of the wetland. You can, when the Nature Conservancy bought the property, it was grazed heavily, and it turns out, in retrospect, that that was probably actually an advantage for Viola nephrophila and the butterfly. Areas that were more open in the bog today was where we found the plant, but we didn't find it elsewhere on the floodplain. So we have many publications that we use to try to help people, and if you're a member, you can get a copy of this Diglacia. And that's I think it comes out quarterly, but there are also information, lots of information on our website. We have a blog. Our local chapter will sends out a newsletter, Sentinel, and hopefully all those things can answer most of your questions. So we have membership levels, a variety of levels. And you can, of course, there are membership levels for much more than this, but these are the common membership levels. And if you need more information about our programs, you can go to our website, and if you do join up, you'll automatically get copies of Diglacia and e-newsletters and notifications about what we're doing. And if you have any about plants or how things work with our chapters, I encourage you to contact me at my Gmail office, or at my Gmail address right here.
Wonderful,
Okay,
Cathy. That's a phenomenal presentation. Thank you so much. Ms. Alyssa, do we have any questions for Cathy?
Hey, we have a question here. How do you anticipate climate change will affect the local heritage plants?
Well, you know, if it does get warmer, it's going to make our heritage gardens and the plants that are to living in bad conditions even more important. We are concerned that one of the reasons that we didn't see the Valoria Celine butterfly is because now it's too hot for it. That's just speculation at this point. More research needs to be done, but I think you can expect a hopefully very slow shift to the north and more plants being able to overwinter here. I certainly have noticed in the last 30 years that I've lived here, I'm in the Sela area just north of Yakima, that plants that never would overwinter before now will come back because they never really died. And also the bugs. I'm seeing a lot more bugs overwinter. So I think that those are, two ways that climate change is becoming more evident.
Wonderful. Thank you, Cathy. All right, so if we don't have any more questions for Cathy at this time.
There is another question here.
Okay, perfect.
Okay. Would Viola nephrophila, sorry about the name there, grow around my pond?
It really is possible. It likes a little wetter conditions. If it's getting lots of sun, and if it was native at one time, or it depends on how disturbed your area is, but it's always possible.
Great, thank you. And that's all we have for questions so far.
Okay, great.
Great, thank you so much, Cathy. So Anne, would you like to introduce our next speaker?
Hi, sure. So our next speaker is Philbrick, and he is with the Education and Outreach, Community Outreach Coordinator for the Canyon Conservancy, and he is going to tell us about the programs with the Cowiche Canyon, and so looking forward to hearing from him. Take it away, Cy.
Thanks, Anne. Can everybody hear me okay and see my screen?
Yes.
All right. Excellent. Yeah, thank you so much, Anne and Cathy, for the support. And I just want to say before I start even, I've been in the Yakima Valley now for about 2 years, and I feel like short amount of time, I feel like there's a groundswell of support in our local area for native plants, and learning more about them, and certainly using them in landscaping. So, and it seems like your program, Anne, is a huge testament to that. So I think it's exciting times in the Yakima Valley for native plants.
Thank you,
my
Cy.
name, yeah, it's exciting. Hello, everybody out there. My name is Cy Philbrick. I work with Cowiche Canyon Conservancy. I'm the Education and Community Outreach Coordinator there. So today, I'll only take about 20 minutes here. I'll touch on a little bit just about the shrub step in general, just kind of a zoomed out perspective about why it's valuable, some of its services that make it valuable as both a provider of biodiversity and for human services. I'll talk a little bit about CCC programs in general, but mostly I want to focus on, because today's about native plants, I want to talk most about just how you might be able to use the shrub step as inspiration for your own gardening or landscaping decisions, for small scale and larger scale community-wide, if there's any city or parks folks on this webinar. And just really quick, if anyone's not familiar with Cowiche Canyon Conservancy, we are a land trust in the Yakima Valley. Our mission is to protect shrub step habitat and connect people to it. So we have three kind of essential program focuses, and those are conservation, recreation, and education. And, Here we go. So I just wanted to start with what is shrub step. Most folks are probably familiar with our, this is our local ecosystem here, but I just like to mention that it's a short definition. It is a type of low rainfall grassland, the most common western states of the US. And I mention it just because I didn't realize before moving out here how essential grass, how essential the steppe part of it was to the shrub steppe. I knew there were shrubs, bitterbrush, sagebrush, but that was something that opened my eyes, walking around. Good representations, healthy representations of the shrub steppe is that grasses really do play a major role. So that's just to say, don't forget about the grasses. And why is it valuable? So I come from a little bit of an ecological economics background. It tends to be human focused, looking at systems in terms of their services to people, which is not the only way to look at them, but these are just a few services that I thought were worth mentioning. So shrub steppe provides erosion control. All those root systems really keep our soil in place. And slide before showed that. Without those root systems, our soil would just wash or blow away, and it's extra valuable here. So in a lot of places, we only have a few inches of it, so we should hold on to it. It helps with water retention, of course, wildlife habitat. Anyone who's walked around the shrub steppe, I'll dive into that a little bit. Just the biodiversity here is incredible. It functions as it has huge value for recreation. That's largely what we see on a daily basis with CCC. There's thousands of people here in the Yakima Valley that use CCC and other shrub steppe trails for physical and mental health. That's largely what people use it for. And then also I want to focus a little bit just on pollination and pollinators, because today is about native plants, and it's hard to talk about native plants without talking about the fact that they evolved in this tapestry of life with pollinators. So anytime you're trying to preserve native plants and work with native plants, you're also de facto pollinators that evolved with them. So just a little bit, I'm really excited to hear Bob Gillespie's talk later on. He's going to dive into some more specifics about identifying individual pollinators. So I won't really get into that, but I just wanted to give a big picture of the value of pollination, both to humans and our ecosystem. So just what are we talking about with pollinators? It's not just bees. Of course, those are the kind of essential workers these days in for our farm economies and in our food systems, but there's tons of other pollinators out there, tons of other insects. You're talking about moths, butterflies, beetles, ants, and birds and marsupials can be pollinators. But of course, bees are the main workhorses. A fact I hear thrown around by the Xerces Society is that 1 in 3 bites that we take, basically a third of our food supply, depends deeply on pollinators. And a lot of that work is done by honeybees, but a whole lot of it is also done by native bees, which are hugely underrated in their importance, economically into our food supply. I think so. Just in the U.S., the most recent stat I read was something like $3 billion worth of our food did by non-honeybees, so non-European bees, by native bees, and a lot of that is just provided for free. So that is one reason to keep large reservoirs of shrub steppe around, because they are also the reservoirs of our wild pollinators. And then just beyond our food supply, our pollinators also keep our ecosystems alive. So again, it's a much higher percentage than the plants that are pollinated. Food supply is just our wild plants, our wild blooming flowers. 9 out of 10, around 90%, rely on pollination of some sort, and that is required to perpetuate plants. So that's required to keep our ecosystems healthy and alive. So I wanted to mention that before. Hopefully, it's a nice preamble to what Bob's going to talk about later. And then I just wanted to mention that this is a value that is impossible to capture really with ecosystem services, but we should protect shrub steppe just for its own sake. I'm blown away on a daily basis. Every time I walk around in the shrub steppe, I realize that it's just a way more diverse place than I could have imagined. It really is an incredible tapestry of life that we have here in the Yakima Valley and around the area. And it's of course plants, but animals, insects, and so much more than that. So yeah, we should protect it just because it is, and just because it exists now. So plants, of course, play a huge part of that biodiversity. Now is the time to see it for sure, especially with all this rain. It's not just sagebrush, which is something I learned coming here. I mean, we have hundreds of species of plants, and they've all evolved ways with unique root systems, unique flower types, colors, and shapes to attract certain pollinators, to thrive in certain types of soil or certain aspects of light. And it's an amazing thing to appreciate walking around in the shrub steppe. So that's another reason to preserve the shrub steppe. It's incredible biodiversity. And just part of forming that, like I said, is part of forming that biodiversity are just the intricate relationships, between plants and pollinators. This is one about the relationship of host plants to butterflies. As part of we have a field trip program at Snow Mountain Ranch called Trail Talks, and we talk about the life cycle of the butterfly. This is actually not this is chokecherry, and I don't think it's the plant or the butterfly that chokecherry is the host plant for. There are a couple different species of swallowtail. Bob could probably correct me, but I think this is a Coronis fritillary, not a swallowtail. But our plants the chokecherry is an incredible pollinator plant. It provides nectar, and it provides pollinators. It provides support for our pollinators for dozens of different types of butterflies. But it's also important to remember that there are certain species, like Cathy was mentioning too, in the Moxie Bog, there are certain species of butterfly that depend on one species of plant. In this case, chokecherry. Without this plant, swallowtail butterflies would really struggle. The larval stage, the caterpillar eats almost exclusively chokecherry. That's the plant that it survives on for its larval stage before it blossoms into a beautiful butterfly. So just something else, another reason that biodiversity is fragile and deserving of protection. So that's kind of the wonderment section of the reasons to be amazed by the shrub steppe. And now I have a couple pieces of that. As folks probably know, shrub steppe is in danger. It has been destroyed at a pretty drastic rate for the last 100 years. This is just one image of the shrub steppe is pictured in the brown. This is just basically eastern Washington. You see, this is around 1900 on the left, basically like the late 1800s, the arrival of white men, basically. And then what has happened, this is like early 20th century on the right. So you see about destruction. But about 75% of the shrub steppe is lost in Washington state, and that's true all over the West. So, largely a story of agricultural development, but other types of development as well. Climate change also plays a role. Just kind of multiple forcing factors on the land, but certainly habitat destruction is the main one. So all the more reason, I mean, you can see now if you hear people talk about the shrub steppe sea, we really did have a sea of shrub steppe on the left only 100 years ago. Now we're really talking about islands of shrub steppe. that's what we're currently working with. And those biggest, it makes the islands that still do exist all the more important and all the more fragile, really. So, you know, lands that CCC manages, the biggest ones are owned by our military, and of course the Yakima Nation, thanks to them, has really kept their shrub steppe intact. So it's important to keep those intact going forward, because it's all we've got now. Some more bad news just on the pollinator front. This publication came out in 2016, 2017 from, I'll have a mouthful, but it's the Intergovernmental Panel of Biodiversity and Ecosystem Services, I believe. And so this is a UN-sponsored organization. It's an affiliation of hundreds of scientists from dozens of different countries. It's really from countries all over the world. It was modeled after, folks may have heard of the Intergovernmental Panel of Climate Change, and the folks who produce every 4 or 5 years produce a massive report on the state of climate change that not nearly enough people pay attention to, our government included. And this is a similar report that has similarly really disturbing news. And it's funny, if you read interviews with some of the scientists who were involved with this report, their main worry is, you know, we spent hundreds and hundreds of hours on this thing, and the main worry is that no one's going to pay attention. So this wasn't just one, you know, scientific study from one university, which that would be reason enough to pay attention. But this is a huge meta-analysis. You're talking about thousands of different scientific studies all over the world, with really, really rigorous vetting. And one of their main headline conclusions was, this is only a couple of years ago, 40% of invertebrate pollinator species are facing extinction. And it, from habitat loss, but it's also from these multi-pronged effects that we have, multi-pronged impacts, or forcing factors that we have for a lot of different reasons. So climate change seems like increasingly one all over the world. It's a multiplier threat. So whatever other threats are facing species, climate change increases those stresses. So if it's pesticide use, if it's habitat loss, all of these things are working at once to decimate our pollinator population. So this is reason to protect our pollinators. If there is any reason, I think it's just a matter of what we can do now. So what does it mean to have species on the brink of extinction? This is one example that's right in our face here in Eastern Washington in the Northwest. A lot of folks are probably familiar with the rapid decline of Western monarchs. It's something that CCC has been paying attention to, because we have a monarch rearing program over the last many years with the help of WSU Professor David James, and a number of volunteers help rear monarch caterpillars as part of a butterfly release party every September. Paying attention just to monarch numbers over the past few years, and it is a pretty tragic trend for sure. Just in the last 20 to 40 years, you know, we've seen a decrease in population from well in the millions in the 80s, over 1 million in the 90s, to at last count in 2019. I don't know what the numbers are this year yet, but you're talking about between 20 and 30,000 individuals of the Western monarch, that is right up against the limit of the population numbers necessary to continue the species. So whether or not we'll have the monarch release party this year is TBD, both from COVID, but also just from a population number standpoint. We may not have the butterflies to release. So that is a sad and tragic story for sure. But there is some good news to come out of that. I think examples of if when tragedy is in your face, it can really, if it's observable, it can spur action. And I think that that could be the case for something like the monarch butterfly. It's such an iconic species that so many people relate to and notice, which is a good thing for human action. A snapshot of a pamphlet we put together for last year's Music and Monarchs release party. Mostly we borrowed it from Xerces Society's Western Monarch Call to Action. There are basically 5 simple things you can do to help support the monarch population. And the good news is that these 5 things translate to basically supporting any pollinators out there. So it's not just the monarch, it translates pretty well. And I added one to the 5, it's just to organize to combat climate change, because that is increasingly clear that that's having an impact on pollinator species as well. So I'll go through that I really want to drill down on is number 1, because it's the easiest one to do, is plant native plants. But also reduce pesticide exposure. You hear about a process or a strategy of integrated pest management, which you can use on a small scale or a large, farm or large landscape scale. And the idea is just to limit or eliminate pesticide use by building the health of your local ecosystem. By bringing in native pest prey instead of out of your plants. So really, a strategy like that can build the resilience of an ecosystem in a farm or a local landscape. Instead of using monocultures or instead of using a lot of pesticides, which are having a negative impact. Number 3, can restore and enhance pollinator habitat. That is hard to do on one's own, but you can support organizations that do so in a large scale, places like the Nature Conservancy, a plug for CCC, land trusts that are working at local scales and regional scales to preserve the tracts of shrub steppe that we have left. Like I said, they are our native pollinators, so it's important to protect those. Combat climate change, participate in research. If you're interested, I can suggest. Basically, I'll point you to the Xerces Society, but there are a couple different opportunities out there if you wanted to get involved with some citizen science projects and observing native bees, or as part of some monarch citizen science. I would encourage everyone to do that, and then also spread the word is another pretty low bar thing that everybody can do. Yeah, more people need to know about the potential collapse of pollinators. So I just wanted to drill a little bit into the first one, plant native plants, because I think it's something everybody can do. You're working with a tiny amount of space outside. If you've just got an apartment garden space, or a backyard, or a kind of a larger, park or cityscape, it's something everyone can do at some scale. And I just encourage everyone out there, including myself, to go out and walk around the shrub steppe and use nature as a teacher, use nature as a guide. A lot of really wise people have said, let nature be your teacher. And I think there's huge amount of opportunity to do that if you're in the planning phase of planting native plants in your backyard. Go walk around, doesn't have to be CCC lands, but go walk around the shrub steppe and see what nature does well already. See what kind of soil and light conditions certain plants like, see what kind of associations are out there. Yeah, so this is one. I think sagebrush there's a lot of plants thrive around sagebrush, which is pretty cool. Sagebrush has 2 different types of roots, two root systems. So way underground with one root system, and then has a secondary one that is much shallower, that it uses to gather water from closer to the soil. top, and a ton of other plants thrive in and around sagebrush, because it does such a good job of bringing water to the surface. So this is just one example. Showy phlox is a species that I see all over the place in and around sagebrush, and there's a bunch of other ground cover plants that do this as well. And Anne and Cathy could probably advise you for your gardens, which would make. So that's one. Right now, walking around the uplands, and this is from a couple days ago in Cowiche Canyon, purple sage is going crazy right now. It's a beautiful plant, and I'm amazed at just how rugged it is. I mean, it is literally growing out of rock walls. So if you happen to have a bunch of basalt in your yard or a canyon running through your yard by any chance, you can plant some purple sage. And I think in walking around places like the canyon, hopefully it can change your perspective a little bit of what's beautiful just in being environment. So I think yeah, you can use this as inspiration for your yards potentially. And ideally, I think our yards and our public spaces could look a little bit more like this. I mean, it's very hard to mimic soil types and conditions exactly to recreate them. But I think if we let the shrub step into our imaginations a little bit more, you might be surprised at what you can create just in and yeah, I think all of our gardens could look a little bit more natural if we let them, if we're courageous enough to let them. And I threw this in this morning. I'm currently trying to plant in my yard. I've taken out a bunch of grass. I'm not courageous enough to show the main area where I've removed a bunch of grass. This is just one fence line that I've planted a bunch of sumac and some rabbit brush, and I've hardly watered it at all, and it well. So that's just one small example of something everyone can do on a fence line or at a larger scale. And I wanted to end just with a couple of Michael Pollan quotes because I think he's a wise dude. This is from one of his first books, I think Second Nature. But these quotes both ring true for me as far as what a garden can be. So first, the garden suggests there might be a place where we can meet nature halfway. And then the single greatest lesson the garden teaches is that a relationship to the planet need not be zero-sum, and that as long as the sun still shines and people can still plan and plant, think and do, we can, if we bother, ways to provide for ourselves without diminishing the world. So I think those are good words to end on, except I just threw in one more slide. Just because I just found out about this program through the Xerces Society, and I just wanted to throw it out to our listeners out there. If anybody knows, so I'm interested in taking native planting and just incentivizing native plant planting onto a larger scale. So this is one potential way to do it. There's a certification program through that encourages sustainability of pollinators through work, basically by working with experts and working with cities, kind of a citywide scale, to create pro-pollinator environments. So if anyone out there has any idea if folks have worked on this, I'm not trying to reinvent the wheel, but if there's a group of folks out there in the Yakima Valley who are interested or have done work to make Yakima a bee city, I think it would be a pretty cool thing to do, and I'm interested in personally helping this cause. a nice thing to do symbolically, but also I think it would be a useful thing for our city, which is so dependent on agricultural dollars. There are only 2 other bee cities in Washington right now: Puyallup and of course Seattle. So I think it'd be cool to make Yakima the 3rd. And that's it.
Sai, thank you. That was a beautiful presentation. Dun, dun. Alyssa, do we have any questions for Sai?
Thanks.
Yeah, we have a comment and then a question. So the comment is just your note that biodiversity is relationships. Indeed. Education message, well done. And then the question is regarding pollinators and biodiversity. How do you view the new murder hornet? How serious is its threat to our local honeybees? Should we welcome them as good pollinators?
Oh man.
Should we protect them?
Wait, sorry, was the last one about our murder hornets pollinators? Is that what that was?
Yes. Let's see. Should we welcome them as good pollinators? Should we protect them because they're pollinators?
Yeah, I will absolutely defer. I'll defer to Bob on the murder hornet. I've only taken a surface, read a few stories. I don't know that much about the murder hornet at all. I don't think, as far as I know, they are not good for our local pollinator populations. But so that is probably a reason to, if we can, eliminate them. But my main worry with the kind of a lot of the freak out stories going on right now is that people will see other wasps, and we've got dozens of species of wasps in Washington State that are pollinators, and that people will start killing native wasps or bees that are actually really pollinators. So I worry about just kind of if the freak out response. But I don't know if Bob can chime in now, but or if he wants to speak on that later, I'll defer to him.
Bob, do you want to chime in here, or maybe wait for your presentation?
Well, I could chime in if you want, or I could wait till after I finish my presentation.
I think we have some time now. Yep. Okay. I'll defer to Heather on that.
Yep, I think we've got a few minutes. Bob, what do you think?
Okay, I want to thank Sai. That was a great presentation and a good lead into pollinators. Murder hornet is an introduced species, for one thing. It does cause a lot of damage in Asia again when it attacks honeybee nest or hives. So that's an issue as well. And it really isn't well established, as Sai is talking about. I think they found like 2 specimens in Vancouver and 2 specimens in Blaine County. So the Washington Department of Agriculture and the agency that's equivalent in British Columbia are really out and doing a lot of trapping and trying to follow the population or the spread of this particular species. But I, like Sai, I worry a lot too, because I want to talk a little bit about in my presentation about wasps, because they get such a bad rap because people are afraid of them, because mainly of the bald-faced hornet and the yellow jackets, because they're social and they will attack in groups, but solitary wasps are careful about that. So my concern, like Sai is saying, I don't want people to start killing anything that looks like this giant hornet, because we're going to eliminate a lot of the native species that are so important as pollinators, and also important in your garden because they'll pick up a lot of pest species as well and help to keep your pest population in a manageable level, and also keep it in more of an ecological balance. So I hope that answers that question.
Yeah, great answer, Bob. Completely agree with you. Any other questions, Miss Alyssa?
No questions at this point.
Okay, well, folks, we are 5 minutes ahead of schedule. That never happens. But we're going to go ahead and take a 10-minute break. We're going to come back at 11:20. So stretch your legs, go grab, something to eat, and we'll come back at 11:20. Fantastic, Bob Gillespie. Thank you so much for joining us, and we'll see you in 10 minutes.
Heather, can you hear me?
Hey, Bob.
Okay, I just wanted to make sure it was working.
Yeah, you are good. In fact, I am now going to change the presenter over to you as we get ready to gear up here for your presentation.
Okay, so I need to show my screen.
That is correct.
All right, there we go.
Ah, I see your presentation. Perfect.
Okay, that's a good sign.
Yes. It's always the first. That's the hardest part. So give folks a few more minutes here and we can grab that cup of coffee.
Yeah, and water to make sure I don't have a problem in between my presentation.
That's a good idea.
Yeah, this is so different, Heather. It's amazing. I think I'm more nervous about this presentation than I am when I'm in front of a group. It's really weird.
I know.
You know, it's talking into the ether is what I've found difficult when I've done presentations like this. You know, it's just a challenge because you don't get that feedback. I feed off the audience when I present, and so just sort of talking out into space is hard.
Yeah, it feels just like a practice.
Yeah, it really does. And I usually like to move around too, and this really doesn't allow that very well. So,
Right.
the other thing, Heather, I wished in a face-to-face presentation, I'm able to bring my collection. And I did such a nice job with this presentation. I've got insects and the plants they're associated with, and that's always helps people make that connection between the plant and the pollinators.
You know, that's huge because pollinators alone, the concept can be somewhat disjointed, but when you pair the two together, it really does help make that connection, strengthens it for.
Yeah, I agree, Heather. It's pretty hard to do one without the other, I feel like.
Absolutely. Well, we have a suggestion for next time. Provide us with photos of yourselves. Yes, we are sort of like the voices talking into the ether.
Yeah, that might be better. No.
Yes. We can definitely do that.
You might scare people. Oh my God.
Well, we do have COVID-19 here, so, you know, next time, hopefully. All right, well, it is 11:20, so we want to honor your time. And so, Anne, I will turn it over to you to introduce the wonderful Bob Gillespie.
Okay, thank you. Thank you, Heather. So our next and final speaker is Dr. Bob Gillespie, an entomologist, retired from Wenatchee Valley College. And Bob is going to take us on a tour of the many different native pollinators attracted to the native plants in the Wenatchee Valley and Columbia Basin. So thank you, Bob, for doing this presentation, and I hope someday to meet you.
I hope you do. Okay, should I go?
Yes, please. Thank you.
Well, welcome everyone. I want to first thank Cy for doing such a great job introducing the pollinators, and I also want to thank all the other wonderful presenters. I hope I can keep up the trend. So what I want to do today is just introduce you to the diversity, some of the diversity that exists between pollinators and flowers. So I'll go ahead and get started. So the first order I'm going to talk about are the Hymenoptera, and they happen to be the bees, wasps, ants, and sawflies. And the reason they're called that is because they're capable of connecting their hind wings and front on the hind wings that connect with a channel in the front wings. And so they're able to unite those when they need to fly for greater surface area, but they can also unhook them and fold them over their back. So when they're moving around in the plants or going from their nest and foraging and things like that, their wings don't get in the road. So. And the other things I like to talk about with them are that I talk about Hymenoptera as the 4 Ps. They're predators, parasitoids, pollinators, and also they're very pretty. And I might be a little bit biased, but some of them are like flying jewels, as you picture right here. This happens to be a metallic green sweat bee, and these are parasitoids that attack insects that feed in wood. And my issue, as Cy was saying as well, is that they are readily recognized, but a lot of people fear them because they lump every Hymenoptera together, and many of them cannot, if they do sting, they're almost unpainful for that, but they do use those stingers for protection and to immobilize their prey. So the first group are the sawflies, and to pollinate, but they don't really have the structures available to pollinate efficiently. But they're separated from the rest of the Hymenoptera by the fact that their abdomen is broadly joined to their abdomen. And bees, wasps, and ants has a basal segment of the abdomen fused to the thorax, and it's separated from the rest of the abdomen by a constriction. So I like to talk about sawflies. If some of you, if you're older in the audience, you realize that at one time when we were young, we had kind of nice indented waist, and as we've gotten older, our waist have kind of broadened. And so that's what I think of as the sawflies. And so here you can see how the abdomen is broadly attached to the sawfly, and here's that restriction we're talking about. This happens to be a bald-faced hornet. Okay, so the sawflies are common on flowers. Like I said, the adults can be they do some pollination, but they also feed on, utilize plant food for their nutrition. The larvae are generally external plant feeders, and a few are internal stem feeders, like the wheat stem sawfly that actually feeds in the stem of wheat and causes the wheat to lodge and fall before it's harvested. Are the larvae, or they look like caterpillars, and they differ from the caterpillars or larvae of moths and butterflies in the fact that they have a greater number of these little prolegs right here. And moth and butterflies, caterpillars have these little hooks on their prolegs that help them hold on to the stem so they don't get knocked off the stem and have to crawl back up to feed. Oh, let me go back. I wanted to mention one other thing. Oh, this one here, these sawflies occur in the forest, stump jumpers, and they really do scare individuals because they have this long structure that emerges from their abdomen, but that structure is not a stinger. Sawflies can't sting. This actually is their egg-laying device or their ovipositor. But when you see that in the woods, when you're walking around, it can actually scare people, and loggers have another name for it, which is can't be spoken in a crowd. Okay, so the wasp, distinguishing wasps from bees. Wasps tend to be generally relatively hairless, and the hair that is on the body is unbranched. The 9% rule, of course, because some of the insects or the wasps don't read the textbooks. And so this is generally how you can distinguish a wasp from a bee, but unfortunately there's a lot of them that grade into other characteristics, and so it can be sometimes difficult to determine whether it's a wasp or a bee based on just looking at it, kind of a gross presentation of a particular insect. The other thing about wasps is they provision their nests with animals rather than plant material. So they collect insect spiders, and they serve as food for, and these organisms serve as food for their larvae. And we were talking a little bit about the murder hornet, and again, there are so many other wasps out there that are beneficial and also important pollinators that to get too nervous about murder hornets at this point in time, I think would be being overzealous about controlling these particular insects. So the wasps are broken down into three major groups. There's a parasitic group, which we call parasitoids, a solitary group, and a social group. The first one are the parasitic wasps, and we call them parasitoids because they are free living as adults, but they live on or in their host as larvae. And these are some of the most beneficial insects for humans as such, because they do attack a major number of insect pests. And you can see they attack caterpillars, beetles, flies, soft-bodied insects such as aphids, scales, mealybugs, and whiteflies. And this is they also, their egg-laying device is not a stinger. This is the ovipositor. But you can see how, wouldn't you like to be this acrobatic? This is a little tiny parasitic wasp attacking an aphid, and it drives its egg-laying device into the aphid, and then it lays an egg. The egg hatches, and then the larvae feeds inside of the aphid, and it turns it into this, we call it an aphid mummy. So the larvae is actually in there feeding, and when the adult is ready to emerge, it'll cut a hole in the aphid, a round hole, and it'll pop out of there, and it'll go out and search for more aphids, because aphids occur in fairly large colonies. So if you happen to be in your garden or your native plant habitat or garden, and you see a large number of aphids, and you start to see these little mummies here, you know that you have parasitic wasps out there. Take that population or lower that population so they don't cause as much damage in your garden or to some of your ornamental plants. The solitary wasp. And again, these are wasps that attack and paralyze their prey to provide food for larvae. And the female has to do all of the work herself. So she's the only provider for her larvae and for herself. And in this case now, the egg-laying device or ovipositor has been modified as a stinger for protection or to immobilize its prey. And you can see here, this happens to be a wingless, this is a mutilid, that the female is wingless. It's actually a wasp, and you can see the stinger, and one of the common names for them is cow killer because the sting is so painful. Here's another one. You can see a little tiny wasp here carrying another insect and taking it to its nest. And over here there's spider wasps that attack spiders, and this actually is trying to attack this spider right here. And what she will do is lay an egg in the spider. The venom immobilizes the spider. Sorry, didn't mean to do that. Immobilize, and then the spider is alive but can't move, and then the larvae feeds inside of the spider. So it's kind of like a zombie as such for the spider. Okay, and so what I wanted to mention too with solitary wasps, they're not likely to sting anybody because, for one thing, they are the only individual that is providing food for their offspring, or if they're going to lay more eggs, creating more offspring. So it's dangerous to sting a particular individual or an intruder, because you always run the chance of being killed. And once the female doesn't have much of an well, that ends up for maybe the survival of her offspring and her ability to produce any more offspring. So they are not aggressive in any way, shape, or form. They are wonderful pollinators. They just don't have the structures like bees do to carry pollen and nectar, carry pollen as efficiently as bees do. But you do see them picking up nectar in order to gain energy so that they can continue to forage and provide, seek out prey for their larvae. The social wasps are the ones that individuals get concerned about, and happens to belong to this group of wasps. So they, for our indigenous or native social wasps, they include yellow jackets, hornets, mason, paper, and potter wasps. And these wasps have 3 castes. There's a queen, the worker, and males. And so the workers go out and provision the nest with mostly insect prey, and the queen and female workers have a very effective sting, and the queen remains in the colony. And the interesting thing about the workers, they're there also to protect the nest, and so what's called an attack pheromone. So if they think they're under attack or they're in danger, they will release this attack pheromone, and then all of the workers will come out of the nest and try to sting the intruder. So this is where people get into trouble, because these particular insects can sting multiple times, and also they have very, very strong mandibles, as you can see right here, or jaws, and so they can actually bite as well. So it's not uncommon for them to come out in mass and sting people multiple times. And if you are allergic to the venom, it's quite easy to succumb to it and fall into anaphylactic shock. So a person that is allergic to venom needs to carry an EpiPen or be very, very aware of the fact that these are an issue. And some of them nest in the ground, and so you can be walking along, hiking, and maybe get very, very near the nest or step on the nest and not know it until the bees start tumbling out of the nest, or the wasps start tumbling out of the nest. And in temperate zones, the colonies survive for just a single season. So all of the workers will die off. They'll produce a bunch of queens, and then the queens will survive the winter to start a new colony in the spring. And somebody talked a little bit about, or asked about, climate change, and this is one of our concerns too. Warmer temperatures, that means more of the queens are going to survive the winter, and that means if there's a greater number of queens that survive, that means there's going to be a greater number of colonies produced. And in the late summer and early fall, when the colony is at its largest, the chances of humans coming in contact with these particular wasps increases dramatically. And so some of the species build nests underground, and others in the open in branches, under eaves, or even in wall voids. So, and I don't know if you've ever looked at one of these nests, but the way they do this is they use their strong jaws to pull strips of wood off of a bark or a fence, and then they use the saliva to masticate it and chew it, and then they actually stretch it out, and they create what looks like paper mache. And you can actually, sometimes in the nest, you can actually see different types of wood colors in the nest. They're kind of attractive once the wasps are gone from the nest. So I wouldn't go look at one of these when they're active. Okay, so now the bees, again, distinguishing bees from wasps. Bees provision their nests with pollen and larvae. So this is a big split between the wasp and the bees. It's using pollen and nectar or plant material to nourish their larvae. As we said, the bees tend to be hairier than wasps, and the hairs on the body are branched, but of course you need a microscope to actually see the branched hairs. They look like little tiny Christmas trees, if you look here on the insect. And like I said, some, like bumblebees, are quite hairy, as well as honeybees, but there are some of the bees that aren't very, very hairy. And then here's some of the structures that have been adapted. This is the pollen basket here, so that they can pack pollen on their hind leg. And then they have these hairs are here and here, and those hairs also help to hold the pollen on the legs. And I have a picture of a honeybee carrying pollen that will give you an idea of what this looks like. And many of you have probably already observed this. So, okay, so there's the solitary bees. These are bees that construct their own nest and provide food for her offspring. There are no workers, and there's no social interaction between the bees. She has no help from other females. She usually dies or leaves before offspring mature. Many of them nest in the ground or above ground in natural cavities. And I live next to the Mount Vernon, found solitary sweat bees actually nesting in the cemetery. So I get a chance to every day check them out and see how their population is progressing and what kind of flowers they're foraging on. So solitary bees are composed of 5 families, 4 of which are common in the Northwest. And I'm going to go through the families, and I don't expect you to remember all this. I just want to give you an idea of what kind of diversity we're looking at. So the first group are the andrenids, or the mining bees. And the reason they're called mining bees is because most of them live in the nest in the ground. And they often form colonies. So there may be, all the females are provisioning their nest. They may be closely associated with each other. And so you'll have large numbers of a nesting population. They're called short-tongued because their structure is short, and they are restricted to flowers that have nectar that's fairly close to the surface of the flower. And again, these are some characteristics I don't expect you to remember, but these are some of the characteristics that entomologists use to place these bees in these particular groups or families. So here's the jugal lobe and the veinal lobe. So we look at that and we say, is the jugal lobe and the veinal lobe almost the same length as each other, or is the jugal lobe very short, or is it non-existent? The andrenids have 2 subantennal sutures here, which are very difficult to see, but this one happens to show up in this particular little bee. And the basal vein is straight right here. And that's, I wished I had made a slide of Don Rolfs is a orthodontist that's been studying bees for about 10 years now. And he has a great flyer that shows the size of bees from this little perdita, which is about this pinhead, to a bumblebee. And so it's really nice to see the size variation of these particular bees, because a lot of us think, well, when we see things on a slide, we think they're pretty good size, and in actuality, they're not that large. So there's about 1,200 species in North America, and they are small to medium-sized bees. And so, you know, pretty indistinguishable. You know, they would look like any other bee, so to speak, but there are characteristics that we look at to try to identify them and understand the biodiversity that occurs out there and in other habitats. The next group are the solitary bees. These are the Callididae, the yellow-faced and plaster bees, or we call them clown-faced bees sometimes, because they have this yellow face. And they're also short-tongued. And one of the characteristics for this particular family, especially this subfamily, is the second recurrent vein is S-shaped. And these are called the plaster bees because they actually line their cells with material that looks very, very much like plastic. And what it does is it helps to keep diseases out of the cell in the nest, and it also helps to create a water barrier so that the cell and the nest doesn't get waterlogged. So they're very interesting bees. So I always laugh and say insects did it first, and so insects were actually producing sheer plastic way before humans ever got into the business of producing plastic. And so this is one of, I can't show you this, but here is that second recurrent vein is S-shaped here. So the next group are the Halictidae, or the swarm bees that often will fly around individuals, and they'll land on your arm, or they'll be very, very close to your arm, and they make people very, very nervous. But actually, they're just looking for moisture and some of the inorganic salts and stuff that are on your arm, and they utilize that for food. So, and what I want to mention with these particular bees, that both the andrenids, the caletids, and the halictids, they're solitary, as I said. But I've been stung by occasionally by these bees, especially the sweat bees, and they just feel like more like a pinprick. It's really not very, very painful at all. Okay, so there's about 500 in America. Again, they're short tongue. I'll show you the basal vein in a minute. They're small to moderate sized bees and often metallic in color. So these things, you remember I talked about the 4 Ps. These bees are like flying jewels under the microscope with the light. They're just beautiful. And then also all of the features and characteristics and structures on these bees really, under magnification, you really get appreciation for how diverse and how beautiful they are. So most of them nest in the ground, mainly level ground or in banks. And a large number of these may nest together and use the same passageways to the outside or entrance. So here's the arched basal vein. So this is what we use to place the solitaire bees, the sweat bees, in this particular family. And then this is this is Agapostamon, and you look at all of the pollen on this particular bee. You can see why they are such great pollinators, with the ability to carry this kind of pollen from flower to flower, and then also take this back to their nest to feed their young. Another solitary bee are the Megachilidae, the leaf-cutting and mason bees. There's about 600 species of them in North America, and now this is a group that have longer tongues, and so they can forage in plants where the nectar is deeper down in the flower. They're again beautiful bees. This happens to be the mason bee. This is the blue orchard bee, or the bob bee, which I have special affinity for because of its acronym. And then here's how the megachilids, or the leaf cutting and mason bees, carry their pollen. Rather than on their legs, they carry it on the underside of their abdomen. And if you're out, especially in the fall, around rabbit brush when it's in bloom, you'll see these bees, and when they're flying around or on the plant, they come up. It's kind of like a butts up appearance, but you'll see all of this pollen on the underside. And then many of you may be interested in promoting mason bees, especially the blue orchard bees, and the alfalfa leafcutter bees are used for pollinating. Well, the mason bee especially for orchards, and the leafcutter bee for alfalfa seed, but they're really important, and they nest above ground in these cells. And you can build these cells yourself, or there's places where you can actually buy these cells. And there's companies that are doing like Knox Cellars that make this available. And Dave Hunter is also has been working on mason bees for a long period of time, and he's a very, very important source for understanding mason bees and the use of them for pollination. Okay, so the leafcutter bees got their name because they line their cells with pieces of leaves. And a lot of people don't like these bees because they happen to cut notches in their rose bushes, and some people have a great affinity for roses. And so they will notch out holes in the leaves, and then they'll use that to line their cells. But if you look at strawberry root weevils will also do this, but root weevils tend to cut a notch, and mason bees are more elongated notch. And these bees nest in natural cavities above the ground, and often in woods or stems. And so like elderberry can be a very, very good source of hollow stems for them to nest in. Okay, so now we're going to turn to the social bees. And these include the honeybees and bumblebees. And Cy mentioned how much native pollinators contribute to our economy. And this is an example as well. Honeybees contribute over $300 million per year worth of honey and beeswax, and that doesn't include pollination. And pollinating activities are worth 130 to 140 times that amount. So they're an incredible contribution. And also native bees contribute dramatically to our food crops, but also to native plants. And bumblebees are being used to pollinate tomatoes in greenhouses because they buzz pollinate. And this is an example where they can unhook their wings and they're not flying, but they buzz at middle C, and they'll knock the pollen right off of the tomato plants, and then they'll land on the anthers of the tomatoes and they'll pollinate. And they're much more efficient pollinators than trying to do it by hand or using honeybees. Now, the problem with this is, and Cy mentioned this to some extent, is that people have been using bumblebees in the greenhouses, and unfortunately, some of those bumblebees picked up a disease in the greenhouse, and then when they escaped the greenhouse, they are spreading some of those diseases into the native bumblebee populations. And so we're concerned about what impact that disease may have on our native bumblebee population. So this Cy talking about all of these different factors that are affecting our pollinators and what we can try to do to mitigate some of those problems. Okay, the honey versus bumblebees. Again, they're long-tongued. The honeybees have a distinct caste system. They have the queen, workers, and the drones. And the honeybees overwinter in a hive. Both the queen and workers survive the winter, but unfortunately the males do not, because the male's main issue is to be there to provide sperm for the female, for the queen, so she can continue to produce larvae throughout the life of the colony. And so the males really don't contribute all that much to collecting pollen and nectar. So they're kind of extraneous, and so they eliminate, well, they don't eliminate them, but they die out in the wintertime, and so they'll have to produce a new batch of males in the spring. So insects don't really put up with individuals that don't contribute to the success of the colony. If they don't contribute, they eliminate them. And the other thing about this is the bumblebees, they're like the solitary wasp. Only the queen survives the winter, and she has to start a new colony each spring. So I always encourage people bees to really give them a wide berth, to allow them to go on and pollinate and collect pollen and nectar so that they can start a new colony, and watch them, and definitely don't collect these bumblebees. If you're going to do any bumblebee collection for an insect collection, wait until late summer to do this, when the worker population is at its highest level. So, and then the bumblebees will have to, the queens will have to find some place, usually in the ground, to overwinter. So bees from other bees, the queens have a longer abdomen than the workers. They have golden brown eyes, and they have hairy eyes, and that's one of the distinguished characteristics of honeybees if you're having problems identifying them. There's very few other bees that have any hair in their eyes. They also have this well-developed pollen basket here, and then I mentioned that I was going to show you a slide where you can see the pollen here on this particular honeybee, and she's carrying it back to the nest. So we excuse me, we are concerned about honeybees and their survival. There's a lot of issues that are affecting them. I actually have a short slide presentation on honeybees and all the factors that are affecting the honeybee population. So apiarists have been very, very concerned about their survival of their honeybees. And so I just want to mention, Cy mentioned pesticides, and especially insecticides. There's the neonicotinoids, or the neonics. They tend to cause issues with the bees because they're a systemic insecticide. And so people actually put them on the plant or on the seed. The insecticide is dispersed throughout the plant. The bees come along and pick up the and it has that neonic, the insecticide in it, and then they take it back to the nest. And so they're causing some issues with the survival of the larvae. But the neonicotinoids are what scientists are finding out is that it changes the behavior of the honeybee, the workers, that they get disoriented and they leave and they can't get back to the nest, and so they'll die outside of the nest. And so you don't see a large number of dead bees like happened with other insecticides. If they were contaminated with an insecticide, you saw the bees died all around the hive. In this case, they don't. They don't come back, and the population just declines over time. And if they can't bring nectar and pollen to the nest for the winter, then the hive really can't survive very, very effectively. So, and there's even some evidence that the neonicotinoids, which they mimic nicotine, that the bees may actually become addicted to the nicotine like humans have become addicted to cigarettes, and they may actually seek out these plants more so than they would a plant that doesn't have the insecticide. So, I mean, this is all research that's going on to try to sort all of this out, but this is some of the issues. So as a homeowner and gardener, if you can of what kind of insecticides have been used on maybe some nursery plants that you're bringing back. You want nursery plants that they haven't used a systemic on, and so you need to know the nursery and have an idea of how they're controlling their pests before you buy the plants. And then utilizing insecticides as much as possible is very, very important. So. And the bumblebees. So I couldn't help but put this in here. If any of you remember the Transformers. So there's approximately 40 species in North America. And bumblebees are very large and robust bees and generally black and yellow, so they're pretty easy to identify. These are some of these are bees that we're worried about as well. There's one species of bumblebees that we are sure is extinct, Bombus frankenelli. Robin Thorpe, before he passed away, was doing surveys in the Sierras, and several years he went to habitat where they were found at one time, and he couldn't find a single one of them. There's 2 or 3 other species that are on the decline, or their range has shrunk dramatically. And again, there's concern about the disease leaving the greenhouses and maybe infecting these populations. Bumblebees are experiencing, as Cy mentioned, habitat loss, so that's very, very important. They're also experiencing pesticide exposure. The insecticide can kill them outright or change their behavior. Herbicides, although they don't actually kill the insect, but they eliminate oftentimes important pollen nectar sources. And then fungicides they're finding that they may reduce the insect's immune system. And Cy mentioned monarch butterflies. This is another one that's of interest as well, is that with the Roundup Ready crops, GMOs, so farmers in the Midwest were spraying Roundup on their crop. The crop is not susceptible to the herbicide, so it kills all the weeds in the crop, but it also drifts and gets into the ditches and areas like that where milkweed grows. And so there's concern that it's eliminating the milkweed and therefore reducing the population of monarch butterflies. So this is a concern as well. And then the other thing that's going on with the Roundup Ready crops is that some of the weeds are becoming resistant to Roundup. And so of course the chemical companies are talking about a new type of crop, a dicamba ready crop that you could spray dicamba on, and it would actually then eliminate the weeds. But unfortunately, dicamba is worse than Roundup. So there's a big concern about the use of that particular type of insecticide in a large acreage like that. So most bumblebees nest in the ground, usually in a mouse or a bird nest. They also like under a rock, or maybe if you have you've collected wood and you have your logs are piled up, you know, there might be a space where they can get in under the ground. I'm trying to find out where the queens are have created a nest in the cemetery right now around, but they're pretty secretive, so sometimes it's pretty hard to find a nest. The colonies are annual. A fertilized queen is the only one to survive the winters, and the first brood is raised by the queen. Once the first brood matures, the female workers take over duties of the colony, including care of the larvae, and then the queen stays there and of course produces eggs. And they enlarge the nest, collect food, and store it in honey pots of wax and pollen. And so where a honeybee hive or colony can have thousands and thousands of bees, a bumblebee nest really may have only 50 individuals or upwards of maybe 500. So it's a much smaller situation. And again, like I said, only the queen survives the winter to start a new colony in the spring. Okay, so I mentioned that I wanted to introduce you to some of the diversity of pollinators. So it's not only bees and wasps that pollinate. There's other orders that also pollinate. And the flies, there's some good examples of fly pollinators. Beetles pollinate. Lepidoptera, the butterflies and moths, and Saul mentioned that. And even thrips. I know most people aren't crazy about thrips, but the males actually can. And then most people don't like mosquitoes either, but the males can't collect a blood meal. And so they actually can be good pollinators because they need the pollen and nectar to survive. Okay, so the first one I want to mention are the dipter, and dipter means two wings. So these flies only have a pair of wings, and then this structure right here, this is a crane fly. This is called the haltere, and so this is their modified hind wings, and they use it like a stabilizer or a flight balancing structure. They fly, it helps to keep the fly upright and flying in a straight line. And you can imagine some entomologists would cut those off to see what happened, and when they did, the fly could only fly a couple inches and then fell to the ground. So these are very, very important in stabilizing their flight. The adult mouth parts are either sucking or sponging, lapping, and this happens to be a syrphid fly. So this is a very, very interesting fly. So they tend to resemble bees and wasps. They can't sting, they don't have a stinger. The adults are great pollinators. They don't have the structures that the bees. They spend a lot of time on flowers collecting nectar and pollen, and they move from flower to flower to pollinate plants. And you can identify this syrphid flies by this spurious vein, which occurs right here. It's a vein that doesn't go to the end of the wing, nor does it go to the base of the wing. And the larvae are really, really interesting because they're predators and they feed on a lot of soft-bodied insects, especially aphids. This happens to be the larvae. And so they will attack, she will lay her eggs near a colony or in the colony. The egg hatches and then the larvae attaches itself to the leaf. It has mouth parts that are like two hay hooks, and it'll just drive its head into the colony and rip an aphid apart and then just suck up the contents. So they're very, very efficient predators. And again, if you see these in your garden or your ornamentals, you know you've got a great predator out there to help manage your aphid populations. So the larvae of many species are predators of aphids. They are maggot-like and usually greenish or yellowish in color. And like I said, they use their mouth hooks to tear aphids' exoskeleton and feed on the internal liquids. This is another one that might scare people. This is called a bee fly. It's mouth parts. It's very, very proboscis. It's very, very elongated. And so it'll land on people as well. And it's basically looking for moisture and maybe a little bit of minerals and stuff that you can find in a human sweat. But when people see this long beak or proboscis come out, they think, oh my gosh, that thing's going to probe me like a mosquito and suck up my blood. But these are really do not cause any problems. And most of them look like little flying bits of cotton. So they have a long proboscis to suck up flower nectar, and the wings are held outstretched when they when the fly is at rest. Whoops. And the adults are usually found on flowers or resting in open areas. And the larvae are, again, important predators. Well, they are in the fact that they parasitize or prey on grasshoppers, but they also attack some bee species. So that's one of the reasons it's called the bee fly, and also because it also gets mistaken for bees as well. And it flies somewhat like a bee. Another group are the tachinids. Most tachinids resemble houseflies, but are larger, and some of them resemble bees. And they usually have these long, stiff on their abdomen. Remember the punkers that used to spike up their hair? Their abdomen looks like that. You can see here and here. And again, they are important predators as in the larval stage. So here's an egg that's laid on a caterpillar's head. The egg hatches, and then the larvae feeds inside the parasitized like cabbage looper, and here's the maggot, and then they pupate in the soil. So there's a large number of these as well, but they're very, very important predators and very beneficial in the garden and yard. Okay, so this is just a list of some other families that pollinate. So the blowflies, the California, sarcophagids, which are the flesh flies, anthemiids, canopids, thick-headed flies, stratomyiids, soldier flies, and even mosquito males that I mentioned before. Okay, the next group are the Coleoptera, or the sheathwings. These are the beetles, and these are the most numerous insects on Earth. They make up over 300, there's over 300,000 species of beetles, and they occur in almost all freshwater and terrestrial habitats. And the reason they're called sheathwing is because their front wings are hardened into a protective shell, which helps them to reduce their water loss, and also reduces predation, and also attacked by diseases. And this is a beautiful one. This happens to be a tiger beetle, and they attack insects on the ground, and so they can run very, very quickly, and they can pick up things like grubs that you might have a problem with, or if you have cutworms and armyworms in your garden, they're a wonderful predator. And both adults and larvae have chewing mouth parts, and they are predators, parasites, pollinators, and plant feeders. So they're fit the 4 Ps as well. So the first one is the metallic wood boring beetles, and they're very, very attractive. As adults, you find them on flowers, feeding, collecting pollen for food. I call them trash and burn pollinators because they'll be feeding on the plant, and in the process of moving around, feeding on the plant, they also pick up pollen and nectar. And so you see them a lot on composites flowers, like the sunflowers and the asters, because there's all of those tube flowers, and so they'll destroy some, but they're going to pick up quite a bit of pollen in the process. They're called, in the larval stage, they're called flat-headed wood borers because of this structure right here. And they do feed inside wood. Most of them feed pine wood, but the bronze birch borer actually attacks birch in the area. And now, if you look around birch trees, a lot of times you'll see the tops of the birch trees are dead. This bronze birch borer is the insect that attacks those. It lays its eggs in the upper parts of the tree, and then the egg hatches, and then the larvae feed in the wood. But some of them can be incredibly attractive. So this one is a beautiful beetle. Clarids, these are all predators. They're the checkered flower beetles. And again, you'll find these on flowers and collecting pollen, and they tend to be hairy, so they do pick up pollen more efficiently than some of the other beetles. Looks like they're very, very voracious predators, and they feed on, oftentimes in the woods, on wood-boring insects, especially bark beetles. Yeah, but there are a few that are pollen feeders. So you can see the hair on these particular beetles. They're quite beautiful. And these are the soft wing flower beetles. These are the malarids. And again, they feed on pollen, and they're predators as, or some are predators as well. And they're very, very important in helping to keep pest populations in check, is this soft wing flower beetle. And this is the one I find most flowers collecting, well, feeding on the plant, but also collecting pollen. And the Cerambycidae, the longhorn beetles, you'll see a lot of these, and some of these are very, very attractive, but the reason they're called this is because their antennae are generally as half as long as their body or even longer, and they will pick up pollen on the plant. And then they're called the round-headed wood borers because they will bore into wood and feed on the wood, and they can cause damage somewhat to living trees, but mainly they attack dead or dying. And our largest beetle in the Pacific Northwest happens to occur in this particular family. It's Prionis energates. The beetle's about probably about 2 inches to 2.5 inches long, and has very, very elongated antennae. And some of you may have actually come across this particular beetle. And the next group are the Chrysomelids, the leaf beetles. These tend to have some pests in this particular family, but again, you'll find them on flowers, and they're distinguished from the Cerambycidae or the longhorn beetles, as their antennae are much shorter than the longhorn beetles, and then they have these tarsal segments are shaped kind of like a heart. But like I said, many are important pests, like the Colorado potato beetle. The asparagus beetles are a problem as well, and some of them feed on ornamentals like roses and things like that. But there are some that are very, very attractive. And I'm not going to go into depth with butterflies and moths, but they are so very good pollinators, as Cy has mentioned. And I think most of you recognize these probably better, but this I had to show you. And I came to entomology late, and so I took my first entomology class, and I saw this thing flying around the flowers, and I thought it was a hummingbird. And then as I looked at it in greater depth, I realized that it was not a hummingbird, it was actually a moth. But look at this long beak or proboscis that goes in there to suck the nectar of the plant, and they can actually hover around the plant almost like a hummingbird. And you tend to see them more near daybreak and then near nightfall. But these are the hawk moths. So I mentioned the swallowtails here, and this is one of the blues or gossamer butterflies. Okay, so usually when I go to these meetings, I have my table of books, but so I didn't have that. So what I wanted to do is show you some great references if you do get excited about bees. This is Bees in Your Backyard, and so this is a wonderful book done by Joseph Wilson and Olivia Carrill, and then they put out this great folder here that's well, it's plasticized, but anyway, it folds kind of like some of the bird guides and things like that. And you can open, covers many of the very, very common bees that you might come in contact with. This is another one, California Bees and Blooms, which is a beautiful guide I know you say, well, it's from California, but a lot of there's so much crossover between plants in California and here and the bee populations that it's a very, very helpful guide. And I've used it a lot in my efforts to identify bees and just learn more about bees and their association with flowers. And then this is another great book, Common Bees of California. And then a couple more, Natural Lawns, and then this is an Xerxes Society publication. And so with that, I believe that's my last. Oh, and this one's another one. This is another Xerxes. This is Attracting Native Pollinators, and this book is invaluable. So. Okay, so I wanted to kind of recognize the following organizations before I end my talk. The Xerxes Society, Cy mentioned them. They are a tremendous source of information, both on the web and in their publication. The Master Gardeners Program. I'm now located in Mount Vernon. I'm working with Skagit County Master Gardeners that are individuals that are very, very interested in native plant gardens, and the research center actually has a native plant garden there where you can go and visit, plus native plants to look at. So I plan to spend my retirement going there and trying to identify the particular bees and pollinators that are associated with those plants. The Extension, WSU Extension Service, the conservation districts, we've already talked about them to some extent, the Natural Resource Conservation Service, NRCS, and the Native Plant Society. And then give you an idea of what I want to do in my retirement. Well, what I want people to place native plants in their yards for, and I'll call them heritage gardens or pollinator gardens. And this will create habitat for wildlife and also for pollinators. And then what I want to do is I want to help people then identify what pollinators are visiting their plants and are associated with their plants. As Cy mentioned, and other speakers have, we are worried about the pollinators and bees, and we're documenting population losses of certain bumblebees, and I've already talked a little bit about honeybees and the issues that they're facing. And the problem is we're losing habitat, and as the speakers have mentioned, and also pesticides are an issue as well. So if you can cut back or not use insecticides, herbicides, and fungicides in your lawns and gardens, this would do a lot to help promote the populations of our pollinators. So with that, I think I'm done, and I'd be happy to answer any questions that I might be able to answer for anybody that has questions.
Bob, thank you so much. That was a wonderful presentation. And Alyssa, I know we have some great questions for Bob.
We do, yeah. And some of these questions came in right as you got started. So one of them is, please address the difference between wasps. And I think we learned that hornets are a type of wasp. Is that correct?
Yeah, that is correct. So they are a wasp, and the difference between them are there's a social wasp, which hornets are social, and solitary wasps, which they have to do all their provisioning themselves, where social wasps, they produce workers, a colony, and so you have the queen, and then you have the workers going out and collecting pollen, and well, in this case, they're collecting insects, meat for their colony. So that's the big difference. And so a social bee is much more likely to sting an individual than a solitary bee, because a social bee has all these. So if they lose a couple workers, big deal, the colony survives. But if the solitary bee dies, you know, trying to protect herself or her colony or her offspring, that's the end of it for her. She can't provision anymore for the offspring that are already in existence, and she can't produce any more eggs. So they're much more reticent about stinging. So I hope that helps.
Yeah, thank you. And then a couple of questions about mason bees and the houses that are available to purchase. What alternatives are available for housing in the garden? And then there's some other questions. Yeah, so alternative using any DIY options, using things like bamboo or raspberry canes?
Yes, you could absolutely do that. Depending, the only issue would be like if you're using blue orchard bees, they have a certain size diameter that they prefer for nesting. So all you'd have to do is just match that diameter with stalks, hollow stalks, and things that you might want to use to create a nesting site for them. And then the only thing you would need to probably be aware of is that over time, like if you use it for several years, actually diseases and stuff can build up in the nest and can actually reduce the survival of the population. So there are like Knox cellars, and they used to sell what were cardboard cylinders, and then you could actually place a paper cylinder inside of that, and then once the bees emerged in the springtime, you could pull out that paper cylinder, and then you could put in a new paper cylinder and that way keep everything very, very clean and disease free. Would they like any more that they would like to know on that particular question?
I think that answers it, but feel free to type into the questions box if you have more questions on that. Question on, have you seen evidence of secondary poisoning in any bird species eating insects affected by neonic pesticides in and around the native shrub steppe or agricultural fields?
I have to answer, I have not seen that. And maybe Cy can answer that better than I can. I would suspect that could be a possibility, but I've been so focused on how it is impacting bees that I haven't really looked beyond that.
Okay. Let's see. Cy, do you have anything to add about that?
No. Yeah, I haven't heard about any evidence of that either. Yeah. But the impact on pollinators is definitely very concerning for neonics.
And I think Cy brings in a good point too. You know, as we saw, insect populations are declining across the board, and so many birds depend on those insects for food that's going to have a major impact on bird populations as well. And we're also seeing bird populations in decline. So there could be kind of a synergistic effect occurring in that situation.
Yeah, that's a great point.
Okay, thank you. And then, do you have any suggestions on the kinds of and weed killers we should be using in our vegetable gardens? I use a DIY soap and oil-based insecticide. Is that bad for the pollinators?
If that person's going to use an insecticide, that's probably the best option. And diatomaceous earth would be another one. So, but some of the botanicals though, like pyrethrum and things like that, they, you know, if it happens to land on a pollinator, it's probably going to have a negative impact on them. But the oils like that and the soaps probably are safest of any of it, as well as the diatomaceous earth.
Great tips. I think that's all we have for the pollinator questions. Heather, we have some questions about if this webinar is being recorded and how people can access it.
Yes, absolutely. So we did record the webinar today. We will email that out if you registered with Anne. She'll email that out directly to you. We'll also post it on our Heritage Garden Facebook page and the website as well. So lots of ways to get the link to the webinar. And I want to thank everyone for attending today. And especially thank you to our presenters for sharing your time with us. The presentations were absolutely wonderful. I want to thank our Alyssa at the Washington State Conservation Commission. They partner with the 45 conservation districts in Washington State to provide us with support. So Alyssa, thank you for your time on a Sunday to help host the webinar.
Absolutely, happy to do it.
Yeah. And Anne, do you have any last words for us before we release everyone to go out in their gardens and weed? Because you know that's what we're all going to go do after this.
That's right. No, I just want to thank everybody for coming, and thank you to Heather and to Alyssa for helping us manage this and all the practice. And Bob, thank you so much for that wonderful presentation. Just was great photos and amazing information. Thank you, Sai, and thank you, Cathy, for all your work and your presentations. I really learned a lot from all of you. So anyways, it's just been a great first experience for me being a part of a webinar. Thank you so much.
Oh, you're welcome, Ann. And the insects do all the work.
True. I'm going to go check out my
So
beehive
take advantage
now.
Wonderful. Well, again, everyone, thank you so much. Enjoy the rest of your weekend and happy gardening. And we hope to see you in the garden soon. Take care, everyone.
Bye-bye.
Bye.
Bye.